this is a quick video how to calculate the stress strain data for the carbon steels. The elastic part is same for high strength steel, cold form steels and mild steel. So this line represent high strength steel, this line represent a cold form steel, and this line represent the mild steels. The equations are given here. I will use Excel to present this one. So let's say from the materials you get this input data. First of all, you can calculate the young strain at yield, which you can calculate using the equations given here, Fy over ES. So you can write Fy divided by ES. So that is your yield strength. Now first, once you get the yield strain, you can calculate the strain and stress. Let's say you have zero stress and you want to calculate a zero stress for that one. We can plus some strain to start with, and we need to go up to 0.025. So we go up to 0.025. That's up to 0.025, and let's say I will just use different colors to represent this first one. To calculate the stresses, we have an equations. It's a straight line equations with the slope of ES. So we are taking the data up to here, and it is Young modulus times strain. So Young modulus times strain, and we not want to change this ones. You can select this one and press F4, or you can put the dollar sign in front to lock that one. So that's calculations done for the first part. Second parts, let's represent using one of the equations. For example, let's say you're working on the high strength steels. For cold form steels, you can use this equation. Let's say I'll show it to you the high strength steel one. So we have these equations for high strength steels. Let me get these equations in our Excel file, so we can see it here. So let me get these equations from here to here. Okay, so that is the equations that we're going to use. Now it goes up to which point? It goes up to the point of 0.05. So we need to have a up to 0.05. So let's get some values up to 0.038 and 49, and it's up to 0.05. So let's get some other colors for this one so we can distinguish. Now for these parts we need to use this equation. So equal to 0.9 multiplied by Fy, and we need to lock it. Press F4 on the keyboard, plus bracket, you have this Fy, which is Fy, lock it, minus 0.9 times Fy, you can lock it, F4, divided by EST. Your epsilon ST is 0.05. 0.05 minus 0.9, and you have this value that we need to lock, and multiply by strain minus 0.9 times this value. So we lock it, and we got these answers. For that, we can just going to use up to here. I think we make a mistakes here. Probably we need to go up to 0.9 FSY. So we can just have a 0.9 times EY epsilon. So we have 0.9 times these ones. We get 0.025. So we can go up to 0.023, I believe. So we can just go up to 0.025. So that is 500, and if I just scroll it down again up to 0.05, we can add 0.025 plus 0.01, excuse me, this value, and we can scroll it up, and 0.023, so 0.023, so 460, let's make it 225 to accurate, 450, that is better. And from here we can add 0.01, so one more zero, so then we can go up to 0.05, we can make it 0.05 here, so that is 500s, and we change it this color to green. Alright, so this is the first, and there is a second one. Now the third ones, that is the equations for the third one would be this one. So we need to calculate this slope of these lines. Probably you know straight line equation for the slope, so you can calculate the slope, ESH. So this let me get these equations, here, so we know that that's the equations for that. So let's put ESH equal to FU minus FY divided by, I think for high strength steels, we are working on high strength steels, is 0.1 minus ESD is 0.05. So you got this slope. Now we have an equations for that, which is these equations that we're going to use up to 0.1. That is the equations for the third part, and we can just add 0.01 to see. We can add 0.01, so it's give you 0.6, and we need to go up to 0.1. We could add a little bit more values, so we can get the less data, and we can get up to 0.1. Yep, almost there, and that is 0.1. That's the 0.1. all right, so that is the last part, and then you can use this part, let's say some different colors, and we can use these equations, which is Fy, I think is Fy. Yep, that is Fy. So we have Fy, lock it F4, or you can type the dollar sign plus these ones, the slope for the last part, that is slope, and you can lock it by pressing F4, and then you can multiply by strain minus 0.005. So you get these values, and this is your full stress strain curves. If you want to plot it, you can plot it in here in that format. Probably there is a small corrections. Probably this one is 470, so 0 point. Okay, we need to remove this point, and because we don't need this point 0.0025, and that's remove that portions, but there is a repetitions here. Probably we need to remove these ones, and we can delete this part, so that will stay as it is now. So that is the one. So if you want to put it in the abacus, you can put it in this one abacus, control V. Probably you want to put it from the plastic one, so you may put as plastic strain 0 here, Probably when I do it, I would put it in just copy format. Probably you need to change it into the true stress strain curves. There is a procedures to calculate in the true stress strain curve. Please check it. That's so this one copy, and let's put it in that format, and we put 0 here, and then from for the plastic one you can put it in the abacus, like in the property, and you want to create, and let's say high strength steel. You can put plastic property, and you can just copy this. So there is a big numbers, which is Control C, paste, and that looks okay. And then we just copy this and put it here. Alright, so that's the video. If you want the elastic property, you can put a Young modulus 200,000 and 0.3 Poisson's ratio. You may need to change it to the true stress strain curves and so on. Probably these values is not appearing perfectly, so probably these values is this one. Yeah, so that looks okay to me. Just copy this only one and Control V. Yep, thank you very much.